Get ready with me while I show you how math is everywhere, including your makeup. I'm gonna go ahead and get started with my primer. Now, primer reminds me of arithmetic because arithmetic is this base that you start with when you're learning math, right? That means numbers, adding, subtracting, multiplying, dividing. These are super foundational concepts and operations, and you have to have them as a basis in order for everything else to stick, just like your primer. Now for the eyebrows. I'm using an eyebrow pencil here that I sharpen, and this makes me think that I could write a calculus problem about this pencil. I could figure out the rate at which the length of the pencil is decreasing as I use it and sharpen it and things like that. And my goal when I'm doing my eyebrows is always to have symmetry across the y-axis. If you took a reflection of this side to this side, you would see the same image. I'm better at math than I am at putting on my eyebrows, so we'll see how this goes. Okay, close enough. Let's move on. Next, we have our foundation. Foundation reminds me of the math that you learn in school, kind of like elementary through middle school. All these concepts that are really going to create this broad basis on which you can learn all other types of math. Algebra, geometry, trig, things like that. So before you specialize and start putting on all your other makeup, you got a good base to go off of. I'm gonna go add some water to the sponge. When I wet this sponge, it gets bigger, and that makes me think of density because we have the same amount of sponge overall, the same mass, but now it's taking up a bigger space. So that means that if density is mass over volume, and our mass is the same, but our volume has increased, our denominator has increased, that means our density has decreased. This also reminds me of smoothing functions, which are functions that we use to smooth out data. Right now I'm smoothing out the data of my face. All right, hopefully that's blended enough. Now let's go ahead with some concealer. Concealer conceals imperfections. It makes things go away. So in a way, it's kind of like multiplying by 0, because when you multiply anything times 0, it becomes 0, and you have no idea what was there before. Just like hopefully now you can't see my under eye bags, or at least not as much. Time for blush. Hear me out. This blush reminds me of a probability distribution. Just like a normal distribution has highest probability as its center, so too does our blush kind of have this center where there should be the most color, and it kind of should taper out. We kind of have these tails as we spread out the blush. Ta-da! I'm adding some bronzer like around my face, sort of like the circumference of a circle, as well as a couple of parallel lines down the side of my nose. Now what? Now I'm gonna use my setting powder. Setting powder goes over everything and kind of adds evenness, which is kind of like when you take a function and you add a constant to it. You're adding the same thing everywhere. Kind of like how everywhere in my face is getting this nice even layer of setting powder. Hopefully. Now why in the world am I talking about math when I'm doing my makeup? I think it is a very good practice to try to find math all around you and to realize that math is not just numbers. A lot of people think of math as how fast can you multiply 37 times 19 or something like that. But in reality, math is so much more than that. I mean, I don't think I've mentioned a single number so far. I could count the number of makeup products I've used, but that's boring. Math is so much more. Math is about patterns and structure and shapes, and it's beautiful, and it's all around you. Anyway, I'm gonna keep putting on my makeup. Now we have eyeshadow. And this eyeshadow here makes me think about rotational symmetry, because in the little eyeshadow thing, a little divot in the middle of the eyeshadow, we could model this with a rotational solid in calculus and integrate it. We could make that into a rate of change problem, because I apparently take the eyeshadow mostly from the center, but sometimes from the edges too. I could model that and try to figure out when I'm gonna hit the bottom of the eyeshadow palette. Next, I like to put a little bit of highlighter in the middle of each eye. So we're gonna have some symmetry across the y-axis of each eyeball. Okay, good enough. Now I'm gonna put on some tinted lip oil. And this also makes me think about calculus, because I could totally model the amount of color that is on my lips over time and how it decreases. And now setting spray. This makes me think of probability again, because wherever I spray it, there's a certain probability of each of the little droplets hitting my face. So how many times do I have to spray around my face in order to get a certain minimum threshold of setting spray across my whole face? And finally, the eyelashes. This eyelash curler has a nice arc on it. An arc is a portion of a circle. And now some tubing mascara. Tubing mascara is tons of math. From my understanding, what it does is it takes each eyelash and it kind of puts a coating of mascara all the way around it like a tube, which sounds a lot like integrating with shells in calculus. And voila, math is everywhere, including my face. Now it's your turn. Go find a daily activity and look for all the ways that math is all around you. I promise it's there.